Welcome to Trigonometry video lecture for section 3.1 on reference angles. Now we found the exact values for trigonometric functions of certain angles between 0 degrees and 90 degrees in the earlier chapters. If you'll remember, we figured out all of the values of the trigonometric functions for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. By using what are called reference angles, we can find exact values for trigonometric functions of angles that are outside the interval from 0 degrees to 90 degrees. So instead of restricting ourselves to just angles that are in quadrant 1, we're going to look at how we can figure out the trigonometric functions values for other angles. So first we need a definition. Let theta be a non-quadrantial angle. Remember, that means an angle that does not terminate on either the x or y axes in standard position. Okay, then the reference angle for theta is the positive acute angle, and we denote it theta with a little r as a subscript, a capital R, formed by the terminal side of theta and either the positive or negative x-axis. So in other words, the reference angle is an angle that's less than 90 degrees measured from the positive or negative x-axis. The best way to understand what's going on is just do some examples. We're going to draw each of these angles in the next example and then find their corresponding reference angles. And like I said, we denote the reference angle as theta with an R subscript. Other times you'll also see theta with a little hat like this, with a caret on top of it. That means the reference angle as well. Sometimes that represents reference angle. Okay. So let's dive into a few examples so you guys can understand exactly what's going on. So first one, 60 degrees. Remember, we're going to draw all of these in standard position. So I'm going to draw an angle, standard position, meaning beginning at the positive x-axis, I'm going to rotate counterclockwise 60 degrees. And that is my original theta. So 60 degrees this way. Here's where the angle is. This is theta. Now, the reference angle is formed by the terminal side of theta. Where's the terminal side of theta? It's right here. That's the terminal side. And either the positive or negative x-axis. Remember, your reference angle is always an acute angle. It's going to be less than 90 degrees. So in this particular case, our reference angle is equal to the original angle, theta. So theta, our reference angle, theta sub r, is equal to 60 degrees, which is the same as the original. That's because our original angle, its terminal side, was in quadrant 1. Okay, let's look at an example where they're not necessarily equal. So 150 degrees, that's our original theta. Let's see where that's going to end up. So I know, starting at the positive x-axis, I'm going to rotate counterclockwise. And then if I go up to the positive y-axis, that's 90 degrees, but theta is equal to 150. So keep going, keep going, keep going. How many more did I go? Well, this is 90 plus another 60 makes this a 150 degree angle. So here's the terminal side. So this whole arc here that's swept out is 150 degrees. That's my original theta. Now the reference angle is the positive acute angle formed by the terminal side. Remember, here's the terminal side and either the positive x or y, positive or negative x-axis. So you're just going to drop down. We're closer to the negative x-axis in this case. And what that means is this acute angle sitting in here is our reference angle. Well, how much is that? Well, remember, if we had gone all the way from the positive x-axis to the negative x-axis, that would be 180 degrees. and we only went 150. So that means my reference angle is equal to 30 degrees. Or you could also look at it like this. We have 60 degrees here, so you would need another 30 degrees here to complete the 90 degrees in that quadrant. All right, next example, we have 210 degrees. First think, what quadrant is this angle going to lie in? 210 degrees. So here's positive x-axis, here's positive y-axis. All the way to the negative x-axis, that's 180 degrees. So if it's 210, we're going to keep going. How much more? It would be 30 degrees more. This is 30 degrees right here. And then this is the terminal side of our angle. Right here, terminal side. Now, drop a perpendicular, if it helps you, to the nearest x-axis. So in this case, the nearest is the negative x-axis. And how much is that acute angle sitting inside there? That's our reference angle right here, theta sub r. Well, remember we went 30 degrees past the horizontal, so our reference angle in this case is 30 degrees. So notice for examples B and C, we had a reference angle of 30 degrees, even though the original angle theta was not the same. Theta in example B terminated in quadrant 2, where theta in example C terminated in quadrant 3. However, they have the same reference angle. All right, let's look at one more here. We have 300 degrees. Okay, let's think. In which quadrant will the terminal side of this angle lie? X-axis, y-axis. So 300 degrees. Just think of it this way. All the way around, one complete revolution is 360 degrees. If we're going 300 degrees, then that means we're short 60 degrees. So that means this remaining portion that I didn't trace out that would have made one complete revolution is 60 degrees. And lo and behold, that's also our reference angle, because here's the terminal side of our angle. And so our reference angle is equal to 60 degrees. So just keep in mind, reference angle is always positive and it's always acute. All right, let's do a couple examples where the angle is negative. So notice here, example E, theta is negative 240 degrees. So let's see, where's that going to terminate? In which quadrant? Remember, when the angle is negative, that just means you're switching your direction, your rotation. So you're going to move in the clockwise direction. We still start at the positive x-axis, but now I'm going to rotate clockwise. That's negative 180 degrees. And then I'm going to go another negative 60 degrees to hit the terminal side. So let's draw the terminal side right here. I'll highlight it for you. And then drop a perpendicular if it helps you visualize better. And your reference angle is sitting inside that terminal side between the negative x-axis, this case, and that terminal side. So how much is that reference angle? Well, let's think. This angle here was negative 240 degrees. So we agreed after we hit the negative x-axis, we went another 60 degrees. So our reference angle, theta sub r, is 60 degrees. Okay, last one, negative 150. Draw these out. You have to draw these out. Okay, x-axis, y-axis, negative 150. I'm going to start on the positive x-axis, rotate clockwise. I'm not going to make it all the way to the negative x-axis. That would be negative 180, but no, this is just negative 150. So there's the terminal side. We stopped there. This is negative 150. Well, how much am I missing so that I would have had to go the full rotation? Because that's my reference angle right there. Had I gone all the way to the negative x-axis, that would have been negative 180. So that reference angle is equal to 30 degrees. Okay. You might want a rule, so I'll give it to you, but don't memorize it. Just draw out the picture the way I showed you. However, if you just kind of want something to use as a guide when you're working on these, here it is. So if theta terminates in quadrant 1, what does that mean? That means theta, its terminal side, ends up in quadrant 1. Then the reference angle is equal to theta itself. And you saw that in example A. Example 1A. Now, if theta terminates in quadrant 2, so here's the original angle theta, terminal side is in quadrant 2, then the reference angle is going to equal 180 minus theta. We saw that for example 1B. Next, if theta terminates in quadrant 3, so the terminal side would be over here in quadrant 3 somewhere. So theta swoops out all the way down there. Then the reference angle right in here is theta minus 180. We saw that for example 1C. And then lastly, if theta terminates in quadrant 4, so terminal side is over here in quadrant 4 somewhere. There's theta. Then the reference angle in here is equal to 360 minus theta. So that was example 1D. Okay, but like I said, don't just memorize these 4 cases because most likely when you're taking a test or something, you might get them jumbled up when you're nervous. So best bet is just practice drawing out the angle and then figuring out what the reference angle is going to be, and it's just going to take a little bit of practice. Okay, now we want to talk about reference angles because we wanted to figure out the values of the trigonometric functions at angles other than just those between 0 and 90. So now we're going to look at values of trig functions in quadrants 2, 3, and 4, in addition to quadrant 1 like we did previously. So if it helps you remember which ones are positive, you could think of all students take calculus. Cheesy, I don't really love it, but some students find it helpful. So here it is. So in quadrant 1, all 6 trig functions are positive. In quadrant 2, only sine and obviously cosecant would be positive. Why is that? Because remember, sine is equal to y divided by r, sine of theta, and so if we're in quadrant 2, y values are positive. If you look in quadrant 3, only tangent of theta and cotangent are going to be positive, everything else is negative. And then in quadrant 4, only cosine and then obviously secant are positive. Okay, you can just think of the signs of x and y and figure this out without having to remember all students take calculus. I don't think it's very helpful conceptually. Okay, so example 2, sketch the given angle in standard position, find its reference angle, and then use the reference angle to find the exact value of each function. Okay, so cosine of negative 420 degrees. So first things first, I know that's bigger than 360, than negative 360, which means we've spun around the unit circle once. So this is the same if I add 360 degrees as cosine of negative 60. Okay, let me explain what I did. I know negative 420 is larger than negative 360. So what happened was we spun around once, that's negative 360, and then we kept going negative 60 more. So I just added 360, that way I don't even worry about that extra loop-de-loop that happened because it's really not going to affect anything when I'm trying to figure out the value of cosine for that angle. So I'm just simplifying it. Remember they're coterminal, cosine of negative 420 and cosine of negative 60, so the value will be the same. So let's draw now negative 60 degrees. It'll terminate here. That's negative 60 degrees. And then let's figure out what's this reference angle in here. So the reference angle is equal to a positive 60 degrees. let's write that down. It's positive 60 degrees. Now you're going to think back to that chart that we had in the last chapter where we had the value of sine, cosine, tangent, cosecant, secant, etc. for all of the angles 0, 45, 30, 60, and 90. Okay, so do you remember what cosine of 60 degrees was? Cosine of 60 degrees is 1/2. Now we have to determine, is it going to be positive or negative? So here's what I think to myself. I do not think all students take calculus. I go, cosine of theta is equal to x over r, and I'm over here in quadrant 4. Are the x values for everything in quadrant 4 positive or negative? Imagine an ordered pair in that quadrant, the x coordinate would be positive. And remember, r is never negative, it's always positive. So that's how I know cosine in quadrant 4 is positive. So I'm just going to leave it as positive 1/2. Okay, good. Let's do another one, sine of 390. Again, I noticed that that's larger than 360, so this is going to be coterminal with sine of 30 degrees. So if we draw out that angle, 30 degrees, it's an acute angle, so its terminal side is going to be in quadrant 1. So 30 degrees this way. And the reference angle is going to be the same as the original angle. So there's the terminal side. And theta sub r is also equal to 30 degrees. So now it just comes down to, did you memorize what sine of 30 degrees is? If not, check your chart really quickly. That's right, it's 1/2. Good. Okay, let's look at a couple more. Cosine of 765. This actually has a few revolutions because once around, one revolution is 360 degrees. If you double that, 2 revolutions is 720 degrees. And I notice this is bigger than that. So I'm going to subtract 720 degrees. And now I know this is coterminal with cosine of 45 degrees. So let's go ahead and see where that's going to be. 45 degrees, that's less than 90. So the terminal side for that angle is going to be in quadrant 1. So 45 degrees is actually exactly halfway. There's the terminal side. And the reference angle is equal to the original angle theta. So theta sub r, the reference angle is 45 degrees also. All right, so do you know what cosine of 45 degrees is? That's right, it's rad 2 over 2. Good. And for all of these, I knew they were positive because we're in quadrant 1. So I'm not worried about having to attach a negative. Okay, let's move on and look at some angles that maybe terminate in other quadrants, spice things up. So sine of 210 degrees. So think for a second, in which quadrant will the terminal side lie? So here's your x-axis, here's your y-axis, 210. So if we start on the positive x-axis to the negative x-axis, that's 180. And then you're going to go a wee bit more, a wee bit being 30 degrees. And there's the terminal side. So can you figure out what that reference angle is? It's the wee bit more that we went. So the reference angle is 30 degrees. And now they want sine of 210. So sine of 210 will have the same magnitude as sine of 30 degrees. It's just the sign may be different, meaning it may be negative instead of positive. So first let's think to ourselves, okay, what is sine of 30 degrees? Sine of 30 degrees is 1/2. But then since we are in quadrant 3, I know both x coordinates and y coordinates are negative. So that means sine is going to be negative. Remember, sine of theta equals y divided by r. R is never negative. So sine of 210 is going to be negative 1/2. Okay, Let's try cosine of negative 135 degrees. Ooh, we're spicing things up. We're adding negative. So that means we're going to rotate clockwise. Let's think. In which quadrant is this angle going to lie? So we'll start on the positive x-axis, but this time I'm going to rotate clockwise. So this would be negative 90, and then you keep going, but not all the way to the negative x-axis. So I'm going to stop there. My reference angle is sitting in here. So if this original theta is negative 135, how much was missing so that I could go all the way to the negative x-axis? Well, that reference angle is 45 degrees, because remember, it's 180 all the way. Reference angles are never negative. They're positive acute angles. Okay, so do we know what cosine of 45 degrees is? It's rad 2 over 2, and then now we have to decide if it's going to be positive or negative. So again, we're in quadrant 3. I know x coordinates and y coordinates are negative. That means if the x coordinates are negative and cosine is equal to x divided by r, cosine is going to be negative in that quadrant. So just add a negative sign on there. All right, very good. One more like this. We have sine of 300 degrees. Okay, so this angle's positive, which means it's going to be swept out in the counterclockwise direction. XY axis, and here we go. So that's 180, 270, keep going, there's 300. What's the reference angle? The reference angle is sitting in there. How much is it? Well, just think to yourself, had you gone all the way around one complete revolution, that would be 360 degrees, but we didn't. We stopped short. We only went 300 degrees. So that means that reference angle is equal to 60 degrees. All right, do we know what sine of 60 degrees is? I hope so. It's rad 3 over 2. And then we have to think to ourselves, is it going to be positive or negative? So we're in quadrant 4. X values are positive, but Y values are negative, which means sine is going to be negative, rad 3 over 2. Okay? If you're having a hard time remembering, just think of it this way. So cosine theta equals X over R, and sine theta equals Y over R. And it goes in alphabetical order because C comes before S in the alphabet, just like, lo and behold, X comes before Y in the alphabet. So you can just remember the correspondence that way, and then determine whether or not sine or cosine are positive or negative, dependent on whether X or Y is positive or negative. Okay. Next ones are pretty fun. Determine whether each function is positive or negative without using a calculator. So we're going to use what I talked about just a second earlier. So sine of 213 degrees, no calculator. All you need to do is figure out in which quadrant 213's terminal side is. So all the way to here would be 180, and then we go a wee bit more, so 213 is somewhere there, okay? So 213 degrees terminates in quadrant 3. So you're going to ask yourself, is sine positive or negative there? That's all they want. They don't care what it's actually equal to, just whether it's positive or negative. Well, remember, sine is going to correspond with the sign of the y coordinates in that quadrant. And in quadrant 3, the y values are negative. So I know over here, whatever sine of 213 degrees is, it's going to be negative. We don't need to actually figure it out. Okay, what about cosine of 210 degrees? Where's 210 degrees going to terminate? Again, quadrant 3. Did you catch that? So here's x-axis, y-axis, all the way to negative x-axis is 180. We go a wee bit more because it's 210. So again, this angle terminates in quadrant 3. Cosine, the sign matches up with the values, the sign on the x-coordinates. So x-coordinates here are also negative, so cosine of 210 is going to be negative. All right, last one like this, sine of 359 degrees. Oh, how funny. So had it been sine of 360 degrees, we would have made a complete revolution, right? Since it's only 359, we just stopped short. Oh no. That means theta terminates in quadrant 4. And then we're interested in sine of 359. Okay, so sine matches up with the y values, and all the y values are negative here, which means sine of 359 is also going to be negative. Okay, beautiful. Now we're going to go backwards. Okay, so example 4 says find theta. So we have to figure out what the angle was, where theta is between 0 and 360, given the following information. So first things first, they tell me sine of theta equals negative rad 3 over 2, and theta is in quadrant 3. So you have to have memorized all of the values of your trigonometric functions for 0, 30, 45, and 60 in order for you to be able to do these problems. As soon as I see rad 3 over 2 and sine, then I know my reference angle, theta sub r, or if you want to put the little caret on it, is equal to 60 degrees. Okay, that you have to put to memory. Now they're telling me theta's in quadrant 3. Okay, so if I need a 60-degree reference angle, but theta's in quadrant 3, that means theta starts here, goes all the way to 180, and then it keeps going 60 degrees more. So that the terminal side's here in quadrant 3, and then there's my reference angle. So this is 180 plus another 60, so that means theta, my original angle, is equal to 240 degrees. So that's all they're asking you to do, is figure out what the original angle was, theta, that got you to quadrant 3, got us to quadrant 3, that had a 60-degree reference angle. The 60 degrees you have to figure out. Okay, let's try another one. So cosine of theta is negative rad 3 over 2, and theta is in quadrant 3 again. So as soon as you see, okay, cosine is equal to rad 3 over 2, don't worry about the negative just yet. That means the reference angle is equal to 30 degrees. That's just from memorizing the values. Okay, we've got a 30-degree reference angle, and then we need to end up in quadrant 3. So super similar to last time. If we're going to go all the way to quadrant 3, remember we start on the positive x-axis. Over here to quadrant 2, that's 180, and then I'm going to go 30 degrees more. That's how I end up over here in quadrant 3 with a 30-degree reference angle. So that means my original theta is equal to 180 plus 30, so it's equal to 210 degrees. All right, very good. Obviously, these are going to be tricky if you haven't memorized those values yet, so do it sooner than later. Example C. Tangent of theta equals -1, and theta is in quadrant 2. Okay, so I know the reference angle is equal to 45 degrees, since I memorized all the values, and they're telling us theta's in quadrant 2. Okay, so reference angle of 45 degrees, we got to end up in quadrant 2. So here I start on the positive x-axis, keep going, keep going, keep going. Stop here, stop. Okay, now the reference angle is sitting down here, and that's 45 degrees. So how much is left over up until the positive y-axis? That's 45 degrees, and this is 90 degrees. So that added together is going to give me my original angle theta. So theta is equal to 90 plus 45, which is 135. Another way to think about it is this. Had you gone all the way to the negative x-axis, that would have been 180 degrees, right? but we didn't. We stopped short 45 degrees. So another way to find theta is to do 180 minus 45, and you still get 135. So either way of looking at it is totally fine. Just do whatever comes naturally to you. If nothing's coming naturally, then just pick one way and learn it. Okay, last one. Cotangent of theta equals -1, and theta is in quadrant 4. So as soon as I see cotangent's -1, then I know my reference angle is, again, a 45-degree reference angle. And this time we're going to be in quadrant 4. Okay, no problem. Here's my y-axis, here's the x-axis. If we are in quadrant 4 and the reference angle is 45 degrees, it swoops out here and stops. If you want to think of it this way, this little angle in here is 45 degrees. And had we kept going, right, one complete revolution is 360 degrees, but we didn't. We stopped short. So that means my original angle theta is 360 minus 45 degrees, which is 315 degrees. All right, very good. Now the next few you're going to need your calculator for, and make sure that you're in degree mode. So on the screen somewhere, make sure it says D or DEG instead of, you don't want R or RAD. That means you're in radian mode. We'll do that later, don't you fret, but right now we're staying in degree mode. And I know we're in degree mode because 1, we haven't learned about radians, and 2, the problem tells us theta is between 0 and 360 with the degree sign on it. So everything needs to be in degrees. Okay, so find theta, find the angle where theta is between 0 and 360 given the information. The directions are exactly the same as the previous example. It's just we need the calculator now because these values here, 0.9652, -9.4134, etc. These are not values that we memorized that were from our table. They're not rad 3/2, 1/2, rad 2/2. They're funky values, so we're going to use the calculator. Okay. So first things first, you want to figure out what the reference angle is. So to figure that out, what you do is punch in sine inverse. So on my calculator, I have to hit second and then the sine key. So sine inverse has that little -1. It looks like an exponent, but it's not. It just means inverse. So you're going to punch in sine inverse of 0.9652. And the problem didn't say how many decimal places to round to, so let's just round everything to 2 decimal places. Okay, we don't do sig figs here, so don't sweat it. Okay, so did you punch it in your calculator? Sine inverse of 0.9652. You should get 74.84 degrees. Okay, but they told me that theta is actually in quadrant 2. This is just the reference angle that we found. Make sure you label it theta with that subscript R. Okay, so let's think here. X-axis, y-axis. We're in quadrant 2. 2, 2, 2, 2, 2. So we got to terminate over here. And what we found right now, the reference angle is sitting down here, 74.84 degrees. That's the reference angle. So how would you figure out your original theta? Well, had we gone all the way to the negative x-axis, that would be 180 degrees. So that means theta is 180 minus 74.84 degrees. So watch, had we gone all the way to this side here, that would be 180, but we stopped short and there were 74.84 degrees left. So that means theta is equal to 180 minus 74.84, which is 105.16 degrees. Whew, I know that can be a lot. So we're going to keep doing a couple more until you get in a good groove, okay? Okay, example B. We have secant of theta equals -9.4134, and theta is in quadrant 2. So most likely you don't have a secant inverse key on your calculator. So remember, secant theta is equal to 1 over cosine of theta. And that equals negative 9.4134. I'm going to put this over 1 just to help us out, because now what I'm going to do is flip both sides of this equation, take the reciprocal. So we would have cosine of theta equals negative 1 over 9.4134. You always put negatives in the numerator or outside. Don't leave them in the denominator. Okay, so now we can use the cosine inverse key on our calculator to figure out the reference angle. And remember, when you're finding a reference angle, don't include any negative signs. You're just interested in what positive acute angle yields a cosine for that magnitude. So ignore that negative. You're just going to punch in cosine inverse of 1 over 9.4134, okay? So let's do that together. So cosine inverse 1 divided by 9.4134, and I have 83.90 degrees. Okay, now they told me theta is in quadrant 2. All right, so let's see here. Here's my positive x-axis, positive y-axis. If we want our angle to terminate in quadrant 2, we're gonna go past the positive y-axis and stop here. The reference angle is what was left over until I hit the negative x-axis. That's my 83.90. So had we gone all the way to the negative x-axis, that would have been 180, right? Do you agree? So that means my original angle theta is 180 minus however much we stopped short, which is the reference angle, which is 83.90. So 180 minus 83.90, that's 96.10 when you round it. Degrees. Make sure you put degrees on all these. Very good. Okay, next example. Example C. Tangent of theta equals 0.5891 and theta's in quadrant 3. Okay, so first things first, let's get our reference angle. So that's going to equal tan inverse of 0.5891. Punch that in your calculator, and you should get 30.50 degrees. Now we have to make sure that's the reference angle, but theta terminates in quadrant 3. Okay, let's see how that would happen. So here's the positive x-axis, here's the positive y-axis. Start here. All the way to the other side is 180, and then we're going to go a wee bit more. How much is a wee bit? In this case, 30.50 degrees more. That way the terminal side is going to be in quadrant 3. So this is 180 and another 30.5. So that means theta equals 180 plus 30.50 degrees, which is 210.50 degrees. Always draw these out. It's going to help you get a feel for the rotation and where the angles terminate. And then later on, you can maybe do it in your head. All right, last one, we have cosecant of theta equals negative 4.3152, and then theta's in quadrant 4. So like example B, we don't have a cosecant inverse button on the calculator, so remember this is 1 over sine theta equals negative 4.3152. Technically that's over 1, right? And remember what we did last time? That's right, we flipped both sides, so sine of theta equals negative 1 over 4.3152. So now it's time to find the reference angle. Don't include any negatives, so you have sine inverse of 1 over 4.3152. And punch that in your calculator. So sine inverse 1 divided by 4.3152, and you should get 13.399. So let's round that to 13.40 degrees. Beautiful. So that's our reference angle. And the problem's telling us that angle needs to terminate in quadrant 4. Okay, no problem. We all know where quadrant 4 is, yes? So here's positive x-axis, positive y-axis. We have to end up in quadrant 4. So you're going to go round and around and around and around, and we stop short right here, somewhere over here. Okay? In here is my reference angle, the 13.40 degrees. Had we gone all the way around and made one complete revolution, that would be 360, yes? But we didn't, we stopped short. We stopped short 13.40, so that means theta is equal to 360 minus 13.40, which gives us 346.60 degrees. Okay, and I'll tell you, this section can be tricky for students because depending on the quadrant, depending on the reference angle, you know, sometimes you do 180 plus, sometimes it's 180 minus, sometimes it's 360 minus. Don't try to memorize a rule. Draw it out every single time. Talk yourself through the steps. The more you understand the process and the reason why, the longer the concept will stick with you. Okay, when you just try to memorize all these random procedures, it's not going to have any lasting meaning or value. So that's it for 3-1 reference angles. I know it was deep, but it's important. Next up is radians and degrees.